Okay, next part, P12, magnetism and the motor effect. So it says, sketch the magnetic fields around a single bar magnet. The crucial thing about this is make sure you label the poles. So I'm going to sketch a bar magnet. I'll put my north this side, south that side. And then I've taught you butterfly, butterfly, straight curve, curve. Be really careful at the ends. So now I'm going to go butterfly, butterfly, straight, curve, curve. Make sure if that's the end of the magnet, it doesn't go from a single point. And then here, straight, curve, curve. That one's a bit ropey. Make sure it's touching the magnet. And then we know that the fields go north to south. So every north needs a line coming from it. North, 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 north to south, and then into the south. Done. Where is the magnetic field strongest? If I just change the colour of my pen, well, it's strongest at the poles. And if I explain why, if I draw a circle that size there and a circle the same size there, we can see this has got 1, 2, 3, 4, 5 lines. So it's got a higher magnetic flux density that we measure in Tesla. This has got 1 line. So now we can see, oh, that's easy. This has got 5 lines in the area. This has got 1. So where is the magnetic field the strongest? Well, it's got to be at the poles. And then explain it in terms of magnetic flux density. There are more magnetic field lines in the same area at the poles than there are anywhere else around the magnet. Next one, sketch the magnetic fields around a pair of magnets in attraction. Ensure you label the poles, so it's giving you a clue. So let's get that there. Let's get that there. Well, I've got a mark for knowing that in attraction I need opposite poles. So if I put a north there and a south there, that's going to be a south, that's going to be a north. We've got a mark already. The next thing now is, well, we're going to generate a uniform magnetic field between these. That's how we make a uniform magnetic field in the lab. Just put a pair of magnets together. And you can see they're going north to south. And then it's the same as the other one. Butterfly, butterfly, straight, curve, curve. Butterfly, butterfly, straight, curve, curve. Now I've got to put lines on everything. Out of the north, out of the north, out of the north. North to south, north to south. North to south, north to south, into the south. And there we go. And that's all the marks. So quite a lot to do for the marks there. A student has 2 magnets and a box of paper clips. So let's say I've got magnet 1, magnet 2, and describe an experiment to measure the strength of the 2 magnets. So I've got paper clips. The important part is when my paper clips are on the desk, that's my dodgy paper clips. There we go. Let's do that instead. There we go. There's my paper clips. And the important part is, well, what am I going to do? I'm going to use it to just see how many paper clips I can attract in a chain. That one's attracted 3. That's 2. You are the stronger magnet. And I recommend just draw a diagram as well to help you. So add paper clips one at a time until no more attract. So I'm going to add a paper clip and then see, can I attract another paper clip? What I've got to be careful of doing is I am not looping the paper clips together. All right, I'm seeing, because ultimately what happens there, imagine that's the south pole. I've got north, south, north, south, north, south. I have induced temporary magnetism on the paper clips. And if I took the magnet away, the paper clips would fall off. So add paper clips until no more attract. Count the paper clips. The one with the most is the stronger magnet. Describe how you could make a permanent magnet. So we learnt in lesson and made this. I think I got you making a compass. The first part then is, let's imagine I'm making a compass actually. So if I get a needle, at the moment I've got to make sure that that is a magnetic material. So it could be iron, cobalt or nickel, but it's got to be a magnetic material. And I need a magnet north to south. And we know that what I'm going to do is stroke that in one direction and then do that multiple times. And this will then align the magnetic fields. So in this needle now, I've got these magnetic domains. That's what makes it a magnetic material, but they're not all aligned. So some will be pointing that way, some will be pointing that way, some will be pointing that way. But when I stroke it, with that north to south, I'm starting to move them all that way. So afterwards, the magnetic domains are all going to have arrows facing that way. It's literally to do with electron spin. And then this one now, I've aligned the magnetic domains. So MD, it's all about magnetic domains. So how can I make a permanent magnet? Get a magnetic material, really important. So state, iron, cobalt or nickel. Iron's easier because it's cheaper. Stroke it with a magnet in the same direction. And the last part is this aligns the magnetic domains. And I've now made a permanent magnet. And that's that done.